A single switch can have multiple VLANs. Here we have VLANs 10 and 20. Traffic is separated between the VLANs to provide security. This is because a VLAN defines a broadcast domain. It is a Layer 3 entity. This is shown by the IP addresses of the PCs. VLAN 10 uses the subnet 192.168.1.0/24. VLAN 20 uses the subnet 192.168.2.0/24. Let us look into the advantages of VLANs in the next slide. VLANs are a single broadcast domain. They can therefore be used to split broadcast domains, decreasing the overhead on a network segment. VLANs can enhance network security because they separate broadcast domains. VLANs allow access to network services based on business function, not physical location. On the topology, PCs A and C could be used by accounting, while PC B is used by sales. VLANs make it easy to add, move, and change hosts on the network. For example, if PC B, used by sales, is reassigned to accounting, a modification in the switch configuration accommodates this. Note, the switch configuration is changed, not the PC configuration. The PC does not know which VLAN it is in. The VLAN is defined on the switch port. Each VLAN has an assigned VLAN ID. Let us discuss VLAN IDs in the next slide. The maximum number of VLANs varies depending on the catalyst switch from 4 to 4094. The table on the screen displays the VLAN ID ranges. The first is reserved, which includes 0, 1, and 4096. The range for token ring and FDDI VLANs is 1002 through 1005. In other words, these cannot be used for Ethernet VLANs. Normal VLANs are assigned a VLAN ID between 1 and 1005. These VLAN IDs work on almost all switches. Extended VLAN IDs are above 1005. Let us continue our discussion on VLAN IDs in the following slide. Extended range VLANs are for Ethernet VLANs only. Normal range VLAN configurations are stored in Flash, VLAN.dat, and can be managed by VLAN Trunking Protocol, VTP. VLAN IDs 1 and 1002 through 1005 are automatically created and cannot be removed. Let us discuss administrative port types in the next slide. There are two administrative port types, access port and trunk port. An access port is assigned to a single VLAN. Access ports are attached to an end-user device. Trunk ports carry the traffic for multiple VLANs. Trunk ports connect switches to non-end-user devices, such as another switch, server, or router. A trunk link must be fast Ethernet 100 megabits or above. Let us discuss switch virtual interfaces in the next slide. A switch virtual interface, SVI, is a logical interface that represents a VLAN. There is no physical interface for a VLAN. The SVI exists within the switch itself. It is similar to a router interface because it is assigned an IP address and defines a broadcast domain. If no VLANs are specifically configured on a Layer 2 switch, there will be a VLAN which defaults to VLAN 1. InterVLAN routing is required to pass traffic between VLANs. This can be done by using a router or a multi-layer switch, MLS. In the topology, PCA and PCB are connected to the same switch. However, for PCA to communicate with PCB, the communication must go through the router. An SVI can be used to assign an IP address to a Layer 2 switch for management purposes. Remember to use Telnet or SSH. A Layer 3 address to reach the device is required. In the next slide, let us understand how VLANs are defined. By default, VLAN 1 is defined. All interfaces belong to VLAN 1 unless they are manually assigned to another VLAN. The two ways to create VLAN are by explicitly defining the VLAN and defining the SVI using VLAN. To assign a VLAN to an access port, configure the SWITCHPORT access VLAN VLAN ID command on the interface. There is no physical interface for VLAN 99, so define an SVI with the interface VLAN 99 command. Then configure the IP address and enable the interface as you would with a physical interface on a router. In the configurations below, 3 VLANs are defined. VLAN 99 is used only to manage the switch. We have looked at access ports and SVIs. Now let us focus on trunks in the following slide. Trunk encapsulation, or tagging, is necessary to keep information about VLANs as traffic is forwarded from one switch to another device. There are 2 trunk encapsulations used by Cisco devices. The first is Inter-Switch Link, ISL. This is Cisco proprietary. ISL has no native VLAN. ISL trunks drop any untagged traffic they receive from another ISL trunk. The other encapsulation is Institute of Electrical and Electronics Engineers, IEEE 802.1Q. Strictly speaking, this is not an encapsulation. 802.1Q tagging inserts a VLAN tag in the Ethernet frame. It then recalculates the frame check sequence, FCS. When encapsulation was discussed in the context of the OSI model, you saw a header and sometimes a trailer was added. In other words, information was added only to the outside of the datagram. 802.1Q tagging inserts a VLAN tag in the Ethernet frame. It then recalculates the frame check sequence, FCS. Since VLAN information is added within the Ethernet frame, 802.1Q, it can support native VLANs and Ethernet traffic. Let us see how tagging works in the next slide. The Port VLAN ID, PVID, is the VLAN ID assigned to the native LAN. If a frame is received on the PVID port, outgoing frames are not tagged. If a frame is received on any other port, it is tagged with the VLAN ID of the incoming access port. If a tagged frame is received on the native PVID, the frame is dropped. Tagging occurs at the first trunk encountered by a frame, before traffic is forwarded to an end-user device. The last switch to handle the frame strips the 802.1Q tag from the frame. In the next slide, let us discuss trunk ports. By default, traffic for all VLANs is forwarded on a trunk. To limit traffic for specific VLANs, use the command given on the slide. By default, the native VLAN is VLAN 1. To change these from the default, use the commands on the slide. Specifying the VLANs allowed on a trunk is considered best practice. It is also a security measure. Connected switches should have the same native VLAN. Otherwise, the following type of error will appear. Native VLAN mismatch discovered on Fast Ethernet 012 with S1 Fast Ethernet 01. Let us discuss Dynamic Trunking Protocol in the following slide. Dynamic Trunking Protocol, DTP, is a Cisco proprietary. It is automatically enabled depending on the trunking modes configured on both sides of the link. DTP supports both 802.1Q and ISL trunks. It sends advertisements every 30 seconds that update the other side of the link with the switch port status. Routers and firewalls do not support DTP. The switch interface towards those devices must manually be configured as a trunk. Let us focus on functions of Dynamic Trunking Protocol in the next slide. DTP determines 3 behaviors. Firstly, it decides whether the interface should trunk or not. If the default is taken, the port is an access port. Secondly, DTP determines whether to negotiate trunking or not. This depends on the option configured on the SWITCHPORT mode command. To disable negotiation, use the SWITCHPORT no negotiate command. Thirdly, DTP determines whether to negotiate encapsulation or not. Refer to the configurations of each behaviors as shown on the screen. In the next slide, let us look in detail at the DTP options in the SWITCHPORT mode command. There are 4 DTP modes used in the SWITCHPORT mode command. The first mode is access. This prevents the use of trunking. The port always acts as an access port. The second mode is trunk. The port always acts as a trunk port. The third mode is dynamic desirable. This mode initiates negotiation or responds to negotiation messages, whether or not to trunk and which trunking encapsulation to use. The fourth mode is dynamic auto. This mode only responds to negotiation messages. The default SWITCHPORT mode depends upon the switch platform. Suppose you have two switches connected with a link. One side of the link can be configured with one mode, and the other side of the link can be configured with a different mode. There are many combinations that can occur because there are multiple options. Let us now look into the DTP negotiation in the next slide. The table shows, for example, that an access mode on one side of the link and other side of the link results in an access link. When you combine access and trunk modes, there is limited connectivity. Depending upon the switch platform, the default mode on an interface is either dynamic auto or dynamic desirable. If both sides are in dynamic auto mode, no trunk forms. It says on the table that the result is an access link. If two switches are not forming a trunk, this may be the reason. For the CCNA exam, you are expected to know all the mode combinations and whether an access or trunk port is formed from the table on the slide. Let us look into the output of the DTP command in the next slide. For general DTP information, use the show DTP command. The output shows the neighboring switches running DTP exchange hello packets every 30 seconds. These are frames that advertise the switch port's mode to attached switches. Use the show DTP interface command to view detailed information about all interfaces that are using DTP. Let us move on to InterVLAN routing in the next slide. A Layer 3 device is needed to facilitate communication between two VLANs. In this section, a router is used for InterVLAN communication. This uses router-on-a-stick configuration. The topology on the slide shows two user VLANs, VLAN 10 and VLAN 20, and the management VLAN of 99. In the following slide, let us discuss router-on-a-stick. On switch S1, FA020 is a trunk. It carries traffic for VLANs 10, 20, and 99. On the router, FA00 is logically split into three interfaces. FA00.10 is used for VLAN 10 traffic. FA00.20 is used for VLAN 20 traffic. FA00.99 is used for native VLAN traffic for switch management. Let us focus on InterVLAN routing using an MLS in the following slide. As can be seen in the image on the slide, S1 in the router-on-a-stick topology has been replaced by a multi-layer switch. The MLS will handle InterVLAN communication. No router is needed here. The configurations for the Layer 2 switches S2 and S3 remain the same. Let us move on to the quiz questions to check your understanding of the topics covered in this lesson.